Let's talk about separable differential equations. These are separable differential equation. In the right hand side we have a product of some function of x and some function of y. Because of the product we can arrange all the y terms in the left hand side and all the x terms in the right hand side. Then we would like to integrate on both sides. If we think that the derivative of y is this kind of fraction dy by dx, then we can multiply with dx and we can then integrate on both sides. We can also think that y is a function of x and there is no problem here to integrate on both sides. So we will separate the variables on different sides, then we will integrate, and then we will solve for the function y. If the functions are difficult, perhaps it will happen that we cannot integrate or cannot solve for y. Here we have some polynomials as functions. We have separated the variables and we are ready to integrate. Here we have done the integration. Here we have written the right hand side in a different way. And this integration constant here, it's just some constant, we can denote it by some other constant. Here is our result. And for this result to be meaningful, we should have that this function inside here is positive. In this example, the integration was easy, but finding the function y of x was a little bit difficult. We had to have some root. Here is another example. We have separated the variables and we are ready to integrate. We have now integrated. Here we have almost found the function y of x. Now this integration constant we can denote in some different way. It can be, for example, c tilde. By taking off the absolute values we can see that this constant can be positive or negative. So maybe we just call this constant a, and a is some real number. We obtain our solution. While calculating, it's also of course fine to check the answer. Now the derivative of y would be this, and we see that y solves the original equation. What would happen if one of these functions here did not exist? In the first case, the function y would be very easy to solve. We would just make the integral maybe an integral like this. How about in the second case? In the second case we would have that, let's see, we would get that we would have to calculate these kind of integrals, and still they seem to be meaningful. In the right hand side we would just get x plus constant and that's fine. In this case we could calculate, we have separated the variables and we are ready to integrate. We have integrated and we can solve for the function y. So also these simple equations are separable equations and they are okay to solve. Here is one separable equation. We can separate the variables and try to integrate. In the left hand side we don't know how to integrate, but in the right hand side we can calculate what the function is. Let's write the left hand side in a little bit different way. The left hand side is a well-defined function of y. The function in the left hand side is a little bit difficult. We cannot make the integration there, and we cannot simplify the function. We obtained the solution in implicit form. Let's solve this equation. I also added a minus sign here, and now we can do the separation, and we can multiply with number 2. Now it is easy to integrate on both sides. We get something like this. So the solution curves are circles. Here the solution is in implicit form. In this case we can also write the solution in explicit form. So now we know how to solve these separable equations. We need to arrange the variables on different sides of the equation, and then we need to integrate. Sometimes we can do it, sometimes not. And after integration we will try to solve for the function y. Sometimes we can do it and sometimes not. In this course, let's try to have such equations that we can solve the function in the end.